In October 2024, NASA's Juno spacecraft transmitted data that changed everything we thought we knew about Jupiter. The core, the massive ball of rock and metal that anchors the largest planet in our solar system. It's not solid. It never was. And right now, it's dissolving into the metallic ocean around it. Juno has 1 year left before Jupiter's radiation kills it. 1 year to answer a question that makes no sense. How does a planet lose its core and still exist? But that's not the disturbing part. The disturbing part is what happens if it finishes collapsing. Every image you've seen of Jupiter is makeup covering something impossible. Those clouds, those storms, the famous red spot. They're window dressing on a planet that shouldn't exist where it is. Jupiter is too big, too hot, too far from where it was born. And somehow, for 4 billion years, it's been standing between Earth and the radiation that would strip our atmosphere into space. But we didn't know any of this until we tried to look inside. And when we finally did, we found something that defies the laws of planetary formation. Here's the problem with Jupiter. You can't land on it. You can't drill into it. You can't even fly a probe deep enough to matter before the pressure crushes it. Mars? We drive robots across the surface. Venus? We've dropped landers into the atmosphere. Saturn? We deliberately crashed Cassini through the rings to collect data on the way down. But Jupiter eats spacecraft. In 2003, NASA sent Galileo into Jupiter's atmosphere to avoid contaminating the moons. The probe was designed to withstand 20 times Earth's atmospheric pressure. It survived 8 minutes, not because it hit anything, because the hydrogen around it got so dense, so compressed, that it stopped being gas and started becoming liquid. The spacecraft didn't crash. It drowned in an ocean made of air. So when Juno arrived in 2016, NASA didn't try to go deep. They went for gravity. By measuring how Jupiter's gravity tugged on Juno as it flew past, down to shifts smaller than a human hair, scientists built the first map of what's actually inside the planet. And the map made no sense. The core was there, but it wasn't solid. It wasn't even in one place. Dr. Scott Bolton, Juno's principal investigator, described it like this. We expected a clean boundary, liquid on top, solid core below. What we found was more like cosmic soup. The core isn't collapsing. It never fully formed in the first place. Jupiter has a blurry core, a diluted core, like someone put a normal planet in a blender and hit pulse, and nobody knows why. But the gravity data revealed something else. At the center of Jupiter, 30,000 kilometers below those clouds, pressure does something no laboratory on Earth can recreate. It turns hydrogen into liquid metal. Here's how that works. Hydrogen is the simplest element. 1 proton, 1 electron. Under normal conditions, those electrons stay bound to their atoms. But at the center of Jupiter, the pressure is so extreme that it rips electrons away and lets them flow freely, like water. That's metallic hydrogen, a liquid that conducts electricity. If you could somehow bottle 1 liter of this stuff and bring it to Earth, it would weigh 700 kilograms. And the instant the pressure dropped, it would explode with the force of a small nuclear weapon. Jupiter has an ocean of it, 30,000 kilometers deep, spinning, churning, generating electric currents on a scale we can barely measure. And those currents create Jupiter's magnetic field. A magnetic field 20,000 times stronger than Earth's. Strong enough to trap radiation from deep space in a bubble that stretches millions of kilometers across the solar system. This bubble is called the magnetosphere. Every orbit Juno makes through Jupiter's radiation belt, the electronics degrade a little more. NASA built the spacecraft with radiation shielding thicker than a bank vault. Jupiter's magnetosphere traps so much radiation that being near the planet is like standing inside a particle accelerator. Then there's the surface, if you can call it that. The Great Red Spot. A storm so large it could swallow Earth whole. A hurricane that's been raging since before the United States existed. It's dying. In the 1800s, astronomers measured the red spot at over 40,000 kilometers wide, big enough to fit 3 Earths inside. Today, it's barely 13,000 kilometers across. In 200 years, it's lost 70% of its size, and nobody knows why. The storm isn't slowing down. The winds inside still reach 400 kilometers per hour, but the spot is shrinking, tightening, compressing into something smaller and more violent. One theory, the jet streams that feed the storm are weakening as Jupiter's internal heat output changes. Another theory, the storm is sinking deeper into the atmosphere and we're only seeing the top. But here's what makes it worse. As the red spot dies, new storms appear. In 2019, Juno watched a storm form in real time. It started as a small white oval. 6 weeks later, it was the size of Texas. Winds inside reached 600 kilometers per hour. And then it merged with another storm and became something we've never seen before. On Earth, hurricanes last days. On Jupiter, they're measured in centuries. And when they die, they don't fade. They get replaced by something bigger. Because Jupiter isn't just covered in storms. It's powered by them. Jupiter is a self-heating engine. It generates its own weather, its own lightning, 1,000 times more powerful than anything on Earth. Its own wind systems that never stop because there's no ground to slow them down. And all of that energy, all of that heat, all of those eternal storms, they're driven by the same core that's dissolving right now. We've sent probes, we've measured gravity, we've mapped magnetic fields, we've watched storms rage for centuries and tracked lightning that could power entire cities. And yet Jupiter remains unknowable, a liquid metal ocean 30,000 kilometers deep, spinning in eternal darkness, a blurry core that never solidified, a magnetic shield we can't survive without, a migrant planet that stopped moving at exactly the right moment for exactly the right reasons, and we have no idea why. Maybe that's the point. Some things in the universe aren't meant to be fully understood. They're meant to remind us how small we are, how fragile, how utterly dependent on forces we can't control and barely comprehend. Jupiter has been protecting Earth since before the first cells divided in our oceans. It will keep protecting us long after our species is gone. And it will do this with a core that makes no sense. Powered by physics we're only beginning to understand, driven by mechanisms we can't replicate. Every time you see that bright dot in the night sky, remember this. You're only here because a planet with a blurry core and a dying storm is standing between you and oblivion, powered by an ocean of liquid metal, wrapped in a magnetic field that's shifting for reasons we can't explain. That's Jupiter, and it's not what you were taught.